of everyone that is in Internet of Things trying to do different things. That's divided by platform, divided by category, divided by building blocks that could be different protocols to communicate, and the kind of different industries that they come from. So when we actually try to translate this into what does that mean for the user and the business, you're actually going to start realizing that it's very difficult for the user itself to try and access all of that. So almost every use case for Internet of Things at the moment requires a specific app to actually do something with an ecosystem. And those ecosystems are not very good at talking to each other. It's not unknown that, for example, Apple doesn't work very well with any other device that is outside of the platform. Same can be said, for example, for Google when the open standards are not used. The same can be said by Samsung and everyone else when they're actually looking at their own ecosystem or smart things, for example. They're not devised and designed to actually talk to each other. And we know for sure that this kind of approach, where there is an app for each one of them, is not approachable and scalable for the user when these things will actually explode. And on the other side, if you look at the business side of things, you're actually going to realize that it's very difficult for businesses to try and understand the reason why they will need something that is an Internet of Things, or try to connect their own devices that are already on some sort of physical connection or network connections to prove the business case. It's very complicated, so unless there is a real reason behind, unless it's actually driven by some sort of business needs that they have, they actually don't see the reason for trying to deploy existing services on top of an Internet of Things device in the way that we consider it. So what if everything was actually just a click away? What if you could leverage the power of the web, which has exactly done the same for anything that is a service that is now interactable with people from a web page onto a device? And this is where the physical web comes in. So I'm just going to have a quick video from Scott Jensen, the main developer. I promise you I won't make it for a bit, it's just 4 minutes long. I'm just going to give you a very good introduction of the use cases behind the reason of the project.
What a great looking movie. When's it showing? Can I see a preview? Nowadays, nearly everyone has the internet in their pocket and access to the world's information at their fingertips. However, getting and interacting with that information isn't always easy.
So where did I put that barcode scanner?
Do I even have a barcode scanner on here? However, if you believe in Moore's Law at all, you can project that there are going to be millions of smart devices in our homes, in our work, and everywhere in between. Accessing functionality from these devices can be just like using the web. You just walk up, tap, and go. Cool, it'll show in just a few minutes. Hello, I'm Scott Jensen, and this is the physical web. So how does this work? The poster is using a Bluetooth low energy beacon to broadcast the URL once every second. The device here can run for 5 years on a single charge. There's a simple scanner on the phone that looks around whenever you wake it up. It won't do any scanning if the phone is in your pocket. The user must always ask to see if anything is nearby. If the scanner discovers something, it'll give you a list to choose from, ranked and filtered to reduce spam, and bring the most relevant content to the top. You select a web page, and it opens, just like clicking on a search result. One of the reasons we use URLs is that they're very well understood and flexible. They can point you to a simple web page with information, a more interactive web app, or an even deep link into a native application on your phone. As these beacons are really just small computers, the URLs can even dynamically change, reflecting a sensor value or even an authentication token. Check out this parking meter example. The user walks up to it and pulls out their phone to see a list of nearby devices. They tap on the parking meter and are taken to a web page. They just add the time they want and hit pay. All of the billing is taken care of in the cloud, and once that's done, it just authorizes the meter. So what's happening here? The physical web URL points to a web page on a standard web server that connects to a small controller unit inside the parking meter. When the purchase goes through, it uses a web socket to message the board, which then adds the time. While the movie poster took you on a journey from the beacon to the phone and then straight to the web, here the parking meter completes the loop, interacting directly with the machine right in front of you, all just using standard web technologies. I want to stress this just a bit. The physical web is only about getting the URL to the phone. Everything else after that is just using the web. In this example, all the real work is done by using the web sockets. That's the idea behind the physical web. Objects can broadcast URLs wirelessly to the area around them. Anyone with a phone or tablet nearby can scan the area, pick an object, and interact with it on the spot. Unlike most apps today, the physical web enables very small interactions, things that you'd never consider using an app for. A dog collar will let you find its owner. A bus stop will tell you when the next bus is coming. You could rent a bike, get a mall map, or even watch a tutorial on a new home appliance. The web is powerful because it works so well for the long tail. Nearly anything can have its own web page. The value of the web is having access to millions of small web pages. This same power can be applied to smart devices and even places. Each one of these physical web interactions is moderately useful, but taken together they demonstrate how letting everything be interactive opens up a new long tail of ephemeral interaction for the entire world around us. The physical web is just an extension of the existing web. Like all web technologies, it's open, and anybody can build on it. Because it uses URLs as the core building block, the entire system is decentralized, so nobody controls it. With the discovery of web pages made frictionless, we're excited to see what kind of next generation experiences developers like you will build on top of the web. Thank you.
Need to get out of it. So okay, now my job here, you've seen the presentation, hopefully you understand better what the physical web is all about. It's just a device for custom URL. We're going to go into examining some of the concepts that were in the video, and then I'm going to give you an idea of the current stand. So if you actually go into the URL that is going to be at the end as well, is you can get download the application and start playing it. So what is it? Well, we were actually saying that the physical web is an effort to try and extend the core power of the web, which is actually the URL, to everyday objects. Okay? And the idea behind that is actually that the premise should be you work to an object that is for custom URL, and tap away, click away, you can interact with the object. And without always without first. Okay, QR codes or anything that works. Even beacons may work in that way, but beacons in the way that are designed, they usually need a little bit more interactions, and they usually deeply into applications. And everything should just be really that way. So if you were looking at the poster example, the idea is when you just walk close to something without no notification, you open up your phone because you were looking at something, and that something is right in front of you, just for you. Why not start? Well, if it was locked down by any other company, then it wouldn't be as open as the web. One of the good things about the web is that you can rely on the specification to be there no matter what the industry does. So this is one of the reasons why we believe an open standard should be the only way to go forward. At the end of the day, okay, if this was an open one and it can be relied on as the web is, then we allow for all those more user cases. We're looking at the color, for example, that wouldn't be feasible otherwise, but they can actually be very well leveraged on if it were just a matter of linking to a page that was already existing. It's just a matter of connecting the device to that URL. In a way, if there is anything that you have to take away from this is very much still an open spec, and everybody should just try and comment on it. It's not supposed to be the way it will work at the end of the day. How does it change things? Well, the idea is for this device to now broadcast a URL, okay? And the dedication, the actual need for a dedicated app is not there anymore. That actually takes away the friction of having to download something to interact with that device. At the base, the physical web is not an explorer. Okay, it's something very similar, and we're going to go into that one a little bit later, very similar to how a search engine would. One of the reasons, and the thing we're going to see afterwards, is you're going to be overwhelmed maybe by the amount of URL that you can have next to you, especially if the technology takes food. But the idea is it's a matter of how you want them for the user to actually make a difference. And again, the simple approach where you can link to something that is already existing and just a matter of getting to it very quickly, it's what makes it different. So why URLs? Again, it's actually something that is very well understood, especially in the web community. It's actually very flexible and can have a lot of different ways of changing the semantics of what you're trying to do. It can be just a tiny part of information that you get at the end of it. It can be a full interactive web page that has authentication, controls, you can have cookies, you can actually bring up whatever you wanted, or it can even be linked into an active application. And this is actually one of the important things. All the use cases that we're going to look at today are actually supposed based on the web, but that's just because that's how we started testing the whole ecosystem. It doesn't have to replace anything else. Actually, that could be a way of linking directly into the app that the user was looking for in the first place. And the use cases, again, we've seen it before, one of the things that can actually make a difference for me is the bus, the tell you the next stop. Not just the bus will tell you what the next one can be, but the bus can actually have live information about what the next stop. A parking meter can actually allow you to charge. A store, no matter how small, can actually allow a user to have an online experience as soon as they walk in. And a share car, or a bike service, like I was saying, could actually allow a car to broadcast a URL that allows you to click on it, sign up, and drive over. And the other one could be industrial equipment and offer diagnostics. So gym equipment can actually keep track of the users and everything you've done. So how does it work? So as we mentioned before, it's the physical web just extends the web that we have. So everything that you already know will still happen. Everything else is just mirrors the basic behavior of our search engine. So the user requests a list of what's in a page, okay, and the way that it does it at the moment is just opening up straight and getting a scan of every single device that is around you. Picks are the thing that you want to interact with, okay, the URL opens on a full-screen browser, and the whole experience is again back on the web. Then if you look at the example from before, this is pretty much what it looks like at the moment. It ain't pretty, but it does the job. The technical version. So if you actually went and downloaded the application as of now from the GitHub URL, you're going to see that actually it's made up of a few different concepts. The first one would be the device itself. The only job of the device is to broadcast the URL to the surrounding area. It uses Bluetooth Low Energy, which is actually quite good because it allows the device to be up and running for up to 2 years, well, 4 or 5, depending on the new concept. It actually requires maintenance. It's built on top of actually the existing URL open standard, which is designed to broadcast URLs, so it's not a hack around how it does. And the URL is stored and broadcasted in the advertising packet of the beacon itself, which is actually the difference. It doesn't require any connection to the beacon itself, which is the main difference of how it works. And again, that has very deep implication about the fact that this allows you to have a lot of beacons in the room without actually conflicting with each other. And on the other side, it allows a user to walk through, pick up all the beacons without actually registering with them. This is for privacy. You can just walk into a room, you can receive all the packets, but you don't have to connect back to any of them. Obviously, because it's in this packet, which is, I believe, 16 bytes long, okay, there is not much space for it, so it will require you to be working around how to address and encode all the information. But at the moment, we expect you to try and play with maybe shorten URLs or find a way of encoding them. There are already like a couple of ways of trying to do encoding similar to what NDEF does when encoding everything that is www.com at the end into a single byte. It's a trade-off, but actually comes with avoiding any unnecessary connection. And again, it goes back to privacy and the fact that it should be completely transparent to the user. It shouldn't be based on notifications. That doesn't mean that the user cannot register itself on notifications at the end of it, but at least it's not going to do anything. The user can ignore all the signals unless he opens the web with the code and scan for something. And the URLs, we will say, that moment are encoded, or at least some part of it. And so the advantage of the design, we said some of them already. First, it's completely passive. Again, I cannot stress this enough. Any number of devices can actually pick up the information and reduce the conflict. Privacy, the user can walk through a room full of those beacons and never register to any one of them. And it's ephemeral. The whole concept of the physical web is not to stress the user with notifications. If you go into a world that actually has 26 devices for each one of the users, if my phone is buzzing at that rate, I think I would go crazy. And the idea behind this is just interact when the user wants to. The client. So the client job is actually to show a list of nearby objects, okay, to interact with. That's pretty much it. One caveat that I have to say, when you're going to go and download the application, if you install it, you're going to see that it's actually an application. That's not the actual code, it's just because we wanted to test the design, and at the moment that's not integrated. So the whole work around trying to make this an open standard is that eventually it will be integrated within the system itself. So it will just be a part of the system that it can work as anything else. So again, just to prove out the technology, so it's not going to be an app at the end of the day. It will eventually be integrated in the operating system. And at the moment, when you look at the example, it's just going to be sorted by signal strength. Again, that's a very happy way of doing it. It's not the best. It's just to prove a concept. Even though when the user is actually in front of something, signal rate, signal strength is actually quite good. But let's try and based on what is close to. and it shows the description, some main information that comes from the URL itself at the moment. And that's another limitation that we'll discuss later. So at the moment, just title, description, URL, and a favicon. Just a way to show that there is some visual next to it. And it's either pulled in real time or cached to a proxy server. That actually ties into the next part of it, which is the server. So the server job is to receive a list of all the URLs that are being picked up by the client when it's opened and scanned by the users, okay, and return a blob of data that contains all the metadata and the ranking for the user to see. So it's not required, apart from the physical web, so it can work already by just having the client. But obviously, the server will actually add a lot of efficiency or a better way of ranking those URLs for the user at the end of the day. The current prototype collects no user data, so it's already returning cache information about the URLs. And alternative implementation though could actually track, if nothing, the user choice and everything that they click on. Again, if you walk into a mall and there are a lot of different stores, you may actually want to have something that just picks up what I usually click on or what I usually go and discover. So if you're already clicking on something, then maybe that's information that you can register, and next time you return the ranking, it can actually be okay. The user usually wants a coffee more than McDonald's actually. So the metadata. As of now, the system expects URLs to point to a web page to provide the metadata that we spoke about before. We know that that's a limitation, okay, because it has to be a valid URL. But the idea is for you to try to come up with the use cases that you may actually want to see and see whether or not the metadata can be pulled in a different way. It's a sneaky limitation because at the moment it doesn't allow to actually get that information about the native application link, for example. But again, that could be addressed by, for example, having a URL that points to a page that will allow the application to be ranked somehow or metadata collected. And here is actually where we need most of the input from you as well, okay, together with a couple of topics at the bottom, which is what else would you like to see? What else do you think is important for the user to see and try to collect? The ranking. So the ranking is actually how you make those choices relevant to the users. So if you go back to the fact that this is just mirroring what the search engine is doing for you, if you think that right now a user is comfortable in going to any website that has a search box, type in something that is very casual, like restaurants, and be returned with millions of results because you realize that in the first page or two, if you're lucky, you're going to get exactly what you want. So the ranking is exactly that same problem. Once you are overwhelmed with a lot of data, what is most relevant for you? So at the moment, again, we're sorting by single start, which is a good start, as mentioned, but the server could do a much better job trying to do that. So we're tracking, for example, the URLs that are the most clicked, and try to see whether or not we can return something based on user preference, or actually tracking personal use. For example, if you know that this one has been tracked while the user was, for example, next to his office, and then that that's more relevant than actually when he's at home and other devices are available. So that could be another way of getting signals about what is more relevant to the user. Any other suggestions you can think of? And if you have any, I'd like to hear them on the Q&A. The last thing to think about is security. Again, this is an open design, not finished. So if you're actually trying to do anything about this, and it goes back to my point, at the moment everything is broadcasted in encrypted. So that comes with a lot of caveats about security and the fact that everything is exposed. So if you need to actually ask you anything is maybe be wary when you try to do this on a personal house, personal home, and everything is actually there because if you limit the range of the device itself for broadcasting, maybe you're safe, but that should never be something that it's out of your mind. Like the idea at the moment is everything isn't clear, keep it in mind, even if for your security or the user security. And to address that one is actually we could turn down the transmitting power of the beacon itself. So if you want to try and keep it enclosed to a room, you could use obfuscated URLs, okay, even though that's not the best security, it's still at least one click away from understanding exactly what's happening around the house. And you can use web authentication mechanisms such as cookies. Again, remember that everything we say here is just a way of connecting a device to the page behind. And then how the page behind works is still part of the normal web day-to-day job. Or you can use a authenticating key at the end of the URL. One thing I haven't addressed here is, at the moment we're talking about beacons because that was actually the best way of doing it. But this technology doesn't work on beacons. Okay, it can actually work with MDNS and I forgot that one. But anyway, it's not just limited to beacon. This one is the actual current implementation, just because Eddystone, as a way of forecasting URL already, gives you a very strong starting point to try and address this. And again, you could use MDNS, for example, on a Wi-Fi network, which is different approach. Any questions?
Oh, thanks. We do have